In this video, we're going to take a look at the application of volume. We are not going to focus on surface area right now. We are only going to focus on the application of volume. So for the first example on volume, Abigail has a cylindrical candle mold shown below. She has a rectangular block of wax measuring 12 centimeters by 15 centimeters by 18 centimeters. How many candles can Abigail make using the wax and her mold? And how much wax will be left over, if any? A great question. So let's take a look. She has a cylindrical candle mold shown below. So let's first find the volume of the cylinder. So the volume of the cylinder is going to be the area of the base, which is a circle, times the height, which is what makes this a 3D shape. So we call that big B for area of the base times the height, and just recognize that the base of this cylinder is in the shape of a circle. So the area of the base, and our base being a circle, means we need to have the area of a circle, which is pi r squared, and then multiply by the height. All right, so they've given us the radius is the 3.4 centimeters, so I'm going to plug that in for my r. So pi, put 3.4 squared, and then I need to multiply by the height, which is that 6 centimeters over there on the side. And we can just say 6. We don't have to put the 0.0. That's just extra work. All right, so let's type that into our calculator. Let me bring up Desmos for my calculator. All right, so let's see. I'm going to get pi, which is down there on the keyboard at the bottom, and then I'm going to multiply that by 3.4 squared, and then multiply that by 6. And so I get a total volume of the candle mold is 217.9 cubic centimeters. And then Abigail said that she has a rectangular block of wax to work with. And so her rectangular block of wax would just look like a 3D rectangular block, and it's measuring 12 centimeters by 15 centimeters by 18 centimeters. So that would be length times width times height, or you can once again think of it as the area of the base, which is a rectangle, and the area of the base is length times width, and then multiply that by the height. And so we just need to multiply the 18 by the 12 by the 15 to get the total volume of the wax that Abigail is working with. So 18 times 12 times 15 is 3,240 cubic centimeters. And so last but not least, we got to make sure we've answered the question. And the question was, how many candles, that was the first question. So how many candles can Abigail make using the wax and her mold? And then how much will be left over, if any? So 2 questions there, and we haven't quite answered those just yet. So we need to take the total amount of wax, the 3,240, and divide by the amount that each candle takes, which would be 217.9, to figure out how many candles she can make. So 3,240 divided by 217.9. She can make 14 candles. She does not have enough for 15, so don't round up in this case. She only has enough to make 14 candles. And then we could see how much she would have left over. So we could say 217.9 times 14. Let's get that number. So that would be the amount of wax she's going to use to make those candles, which is 3,050.6 cubic centimeters. So we just have to take the total amount, 3,240, and subtract the amount she's going to use, and we'll have the leftover amount. So 3,240 minus the 3,050.6, and she has 189.4 cubic centimeters of leftover wax. All right, we just had to find the volume of both, figure out how many candles she can make, and then subtract to get the leftover amount. So we're done with the first example. We're going to skip the example for Bob and his bookcase for now, because that is on surface area. We're going to skip the imaginary toy company because that's also talking about surface area, and we're going to look at the donut shop example. So the donut shop just received their new container for their donut holes from corporate. The customer asked how much more will fit in the new container than the previous. Pictured below is the new container. The height is 5.71 inches, the width is 3.94 inches, and the length is 5.12 inches. If the length increased by 0.42 and the width increased by 0.24 to create the new container, how much more space is there in the new container? We'll just put a comment right there. All right, so this is our new container. So let's see, new container, and all they gave us was length, width, and height. So let's multiply that together. Length times width times height. We wouldn't have enough information to truly try to estimate this as the shape that it looks like, so we're going to treat it like it's a box. So let's say 5.71 times 3.94 times 5.12. So the volume of the new container, let's just multiply those together. Let me clear out my calculator. All right, so I got 5.71 times 3.94 times 5.12. So I get 115.19 cubic inches is the volume of the new container. So let's figure out the previous container. So if the length was increased by 0.42 and the length originally was 5.12, then we need to subtract to figure out the old length. And then it said the width was increased by 0.24 and our width was 3.94, so we need to subtract to figure out the old width. So let's just do some quick math there. So 3.94 minus 0.24 gives us 3.7 for the old width. And then 5.12 minus 0.42. Whoops, let me start a new row. 5.12 minus 0.42 is 4.7. So that was the old container's length. All right, so we have the old width, the old length, and the height stayed the same. So I'm just going to write old container, or you could put previous container. So it's still length times width times height. And we just have 5.71 times 3.7 times 4.7. All right, so 5.71 times 3.7 times 4.7. So we get 99.2969. So let's say 99.30 cubic inches. Now check your work and see if you've answered the question they asked. So it says, how much more space is there in the new container? So we have the volume of both containers, but we have not answered that question yet. And so let's take the volume of the new container, so 115.19, and subtract that volume of the old container to figure out how much more volume we have now in the new container. So 115.19 minus 99.3 is 15.89 cubic inches more space. All right, so that's it for our example of the donut shop container. Let's take a look at the juice container example below that one. It says a juice container is a square prism. I'm gonna clear out my calculator. Is a square prism with a base edge length 4 inches. The height of the container is 8 inches. How much juice will the container hold? So it looks like a rectangular, or they said a square prism. So it's a square prism. Oops, wrong button. If it's a square prism, then we multiply the area of the base times the height. So for any type of prism, you can do that. Simple idea. And the base is a square, so that would just be length times width, and then the height. All right, so then the length and width are both 4, because they told you that in the problem. And the height, they said, was 8 inches. They just didn't label it, but we can just add that in. And it says, how much juice will the container hold? So that's a pretty straightforward question. We can just multiply 4 times 4 times 8, and we get 128 cubic inches for that one. So we've answered the question, how much juice will the container hold? Sometimes they are just simple volume questions. We're going to skip the one about the building a shelter, and we're going to take a look at the next juice box problem for our last example. But we're not going to calculate the surface area. We're just going to focus on which container has the greater volume. So this first one is a cylinder container. So remember, a cylinder has an area, or excuse me, has a base that's a circle. So we've got to find volume is the area of the base times the height. And the area of the base, which is a circle, is pi r squared in this case. And then we're going to multiply that by the height. Now they've told you that the entire width of the can is 6 centimeters. So the radius would just need to be half of that, which would be 3 centimeters. So let's fill in pi times 3, which is our radius, squared, times the height, which was the 9 that they wrote over there on the side of the can. And they've labeled that it goes from the top of the can down to the bottom of the can. All right, so let's calculate. We've got pi on our keyboard at the bottom. We're going to say 3 squared times 9. So we get 254.47. 254.47 cubic centimeters for the cylindrical juice can. And now we need to compare it to the square prism, like the juice box. So for the juice box, we have the volume is still the area. I'm going to write with the different color. The big B stands for the area of the base. The base in this case is the rectangle. And so rectangles have an area that is length times width. And then we always multiply by the height to calculate volume. So we need to multiply length. So length is the 5. The width is the 5 they gave you up here at the top. And the height was the 9 centimeters over there on the side. All right, so let's calculate 5 times 9, and we get 225 cubic centimeters. And they asked, always refer back to your question and double check you're answering the question. It said, which container has the greater volume? So you just have to compare these two. We had 254.47 in the first container compared to 225 in the second container. And so the winner is definitely our cylindrical juice can. So, cylinder has the greater volume. All right, so that's just a couple quick examples for application of volume.